Mission Solar Energy is a U.S. solar panel manufacturer serving utility, commercial, and residential applications. This video will introduce you to our quality control process and the dedicated team members that maintain it. Thank you for choosing Mission Solar Energy.
Solar technology will change our world by providing clean, accessible power to communities across the globe. Our solar panels go through a rigorous process from the very beginning. It all starts with incoming inspection, where we ensure that only the best raw materials enter the line so that you get high-quality solar panels.
The receive and inspection process for the cells involves a shipment coming in. Once that shipment is received here at Mission Solar, we actually take a sample of the total lot size. So the total amount of the shipment that comes in, we take a sample based off the C=0 sampling plan, and we produce it with a AQL or an allowed quality limit. From that sample size, we begin the inspection process. From that point, we actually cut open the box and we take each cell out, and we check the block of cells to make sure that there's no damages, cracks, chips, any color differentiation, any other damages that we could see. And we actually use the microscope to inspect to ensure that dimension-wise, the measurements are accurate. What we're looking for with the microscope is to make sure that the bus bars on the cells are actually the correct distance apart. They are also the correct length, and we ensure that the dimensions of the cell itself are accurate, such as the length and the width. Once the cells are inspected on the microscope and are approved, we then notify supply chain as well as production just to inform them that the lot is accepted.
Cells that meet the inspection requirements continue to the front end of the process line. Jesse, after the cells are inspected and we give them to you, what are you doing?
We take the cells out of the solar package. We check for any type of cracks, anything visual on the edges, any chips. Once we're done with that, we load the cassette into our vision system that checks 100% of the cells, looking for micro cracks, any chips, or anything that the vision system will detect. The cells then get stringed together, whether they're stringed together in 10 cells or 12 cells. Then they go to the operator's visual inspection process. The operator's looking for, once again, any cracks or chips around the edges, any soldering issues that can be either missing ribbon, not soldered down properly, or solder balls. We're also looking for burnt ribbon or any issues of alignment. Once it goes into the layup process, it's actually transferring the cells over to the Y-axis and the X-axis aligner. What that does is it aligns the strings either in width or length on the positioning of the module. Once that is complete, it transfers the strings over to the solder table, where they then solder the bus bars onto it, completing the array process.
So after layup, it goes into manual inspection. What's the criteria that your team is applying?
The first thing that we look on the inspection process is checking any dimensionals on string to string or string to bus bar. We also check string to the edge of the glass, make sure that everything is aligned properly. We visually inspect for any cracks or chips or any ribbon issues that we might see. We also focus on all of the string to bus bar solder points. We confirm that all the soldering is completed on both the front and back side of the module before we send it on to our next process. They do install their installation patch that divides the bus bars so that they're not making any contact to eliminate any no polarity or current issues. Once that's completed, they install their top EVA, confirming that the EVA is covering the cells and the glass. And once that's complete, they install their back sheet, doing the same thing, confirming it is covering the whole module as they place down a positioning tape.
Once the cells have been inspected at these stations, they continue to an EL test, or an electroluminescence test. During this test, current is passed through the module and the solar cell emits infrared light. An infrared camera is used to capture that light to detect microcracks or invisible to the naked eye cell processing issues. We're at the auto trimming station right now, but before auto trimmer, we go through lamination. Can you describe that process?
Sure, James. The primary function of the lamination process is to encapsulate the solar array between two sheets of EVA, the back sheet and the glass. And the reason for doing that is we want these panels to last 25 years or longer, and that process allows us to do so.
Great, so after the lamination cycle, it comes out and it goes to post-lamination. What are you looking for there?
Well, there's two parts to that inspection. In the first part of that inspection, we are looking for imperfections on the back sheet, air pockets, scratches, or anything of that nature. From there, it goes to the rollover, which we call the sun side of the module. From there, we inspect to make sure the spacing is correct between the cells, all the ribbon is soldered in the proper spots, and that there's no contaminations in the solar array. The framer basically installs 4 pieces, 2 corners and 2 long edges. Before we can install the frame, we have to put silicone in the groove of the frame. This allows us to seal to the module after 24 hours. Inside the frame there's a groove, and before we put the frame into the framer, the operator will look inside the groove and make sure there's a proper amount of silicone in each and every frame.
From there, we are going into the J-box station.
At the J-box station, we apply silicone sealant all the way around the perimeter of the J-box. We then install the J-box through the 4 leads and hook those 4 leads up with the spring-loaded tie-downs. This gets us ready for the power hookup.
At the J-box station, the frame and module are inspected and the sealant is applied. At both the framing and J-box stations, the weight of the silicone application is monitored using statistical process control. The bead placement is visually inspected to ensure a solid seal. Additional safety and performance tests are conducted, including a flash test, high potential test, and a second EL test. When a panel passes all of these tests, it is now ready for outgoing inspection. This is the final inspection station. Would you go over what you are looking for here?
Sure. First thing we look for is the frames to make sure there's no scratches or damages. It can affect the mounting process, and also is a cosmetic issue. Second thing we look for is the back sheet. I want to make sure that there's no scratches or penetrations through it. It can add moisture in there and can eventually down wattage the whole module itself. Third thing we look for is the J-box. I want to make sure that it has a nice applied sealant and there's no moisture can get into it. Also with the top, make sure it's clamped down all the way to also provide no moisture gets into it. And the last thing we check for is the front side, just a cosmetic issue. Make sure it's nice and clean. All these 4 things are important to provide our customer a good quality product.
Mission Solar Energy is passionate about manufacturing state-of-the-art solar products that are high power and guaranteed to last. We are committed to continuing to provide the world with innovative solar technology through continued research and development.